some upgrades that we recently did in the High Performance Computing Center at Michigan State University. High performance computing, it's a large cluster of computers operating as a shared resource, typically in a batch processing scenario. I will talk about some of the constraints that we had to begin with, and then how we evaluated the options for us to move forward, the rollout plan we used to try and make it a success across the thousands of users that we support across Michigan State University, and all of the various research topics that they're trying to use computing for. I will talk about some challenges we found along the way, and then I'll kind of close with some of the successes we've had and the things that we'll bring moving forward. So some of the constraints were the upcoming CentOS 7 end of life date. That sort of puts that impetus on us to hurry up and get it done before that date arrived and no more updates were provided. We did want to deploy it with our current deployment tooling, which is a product called XCAT, which is Extreme Cloud Administration, which allows us to deploy images across the 1,000 compute nodes with rapid and remote activity. We do run 6+ generations of compute nodes, ranging from 2014 hardware all the way through 2023, with the recent addition of some Grace Hopper GPU nodes from NVIDIA. Our older hardware was still providing user services, typically virtual desktops to classrooms. So we didn't want to lose any of that hardware as part of this conversion. We do provide a local software stack of about 1,000 different versions, tool chains, and software for researchers to use, all the way from Fortran compilers to C compilers and specialized research software that has been developed by the community using some of those tool chains. We did want to continue to manage it with our current configuration management system, so we had to incorporate that in whatever product we were doing. And we have a historical code base for our configuration management that we did need to consider and make work with whatever we chose. And then finally, as always, there's the team knowledge base. If it's the best product but nobody knows how to use it, it might be a bridge too far. So that's the final key. We started ruling out some unreasonable things. Arch Linux, Gentoo, NixOS. There's a lot of maintenance overhead, and we didn't really have the team knowledge to put any of those solutions into place. SUSE Linux and OpenSUSE, same thing, team knowledge. Our tooling wasn't really set up for it, and we didn't hear about a lot of adoption in the US high-performance compute environments. So there wasn't a large base of people we could reach out to ask questions. CentOS Stream, which is what CentOS changed into, I think it's very interesting, but we really don't have any Linux developers on staff that make it useful to run something that's leading edge that we can do patches on and provide upstream. And the other thing is there were some other high-performance computing centers that had reported stability issues with running CentOS Stream, and we really needed to run a stable but also agile environment for our users. We want the latest stuff, but we also wanted it to be in a stable configuration for all the researchers. And then finally, the container systems is likely an option for many places, but because a lot of our users compile their own software, it wasn't really a good fit for our use case. So that left us really with two options. There's RHEL 9 and the associated clones. We didn't look at 8 because we don't want to have to. We wanted to go ahead and make the jump at the time to the newest version we could, to give us a longer shelf life of the operating system for our users. First thing we found was that Alma was not supported on our deployment tooling. So that kind of left that out because it would have required us to write some manually tooling or switch which product we use to actually deploy it all. And then we also found out that all of the RHEL 9 clones lack support for hardware some of the hardware we're using from 2014 and 2016. And we really didn't want to lose the use of that hardware as part of this OS upgrade. And then finally, RHEL itself would add another step to the process and then we might see some license management challenges at scale. So we didn't really want to take on having to manage the licenses. One of our troubleshooting tools is, we'll just reimage the whole machine and start from scratch. And having to manage licenses as another step in that process was slightly unpalatable to us. So we also looked at Debian and Ubuntu. Debian cadence, personally, we kind of thought that the cadence was too fast. They're on more of an 18-month to 2-year release cycle. But the Ubuntu life cycle of 5 years support without having to pay extra is certainly within the realm of that's a usable life cycle. It was well supported on the deployment tooling with the exception of some small issues. And then we had a lot of Debian derivative experience on staff. We have people that have run Debian environments and then also people who have used Ubuntu at home. And then our older hardware, Debian and its Ubuntu derivative, they had support for all that older hardware out of the box. We didn't even really have to search or try to rebuild drivers to match it. So we were set up for success with Ubuntu, and that's what we moved forward with. We did try some deployments as we were moving through, and did early work in our configuration management to kind of, even before we had decided on an OS, we did work to make our configuration management support whatever OS we chose, instead of just failing and requiring a lot of work to get it back to an operational condition. We'd be able to deploy almost anything and get the configuration management to work. So we developed I would say, aggressive migration plan because we did it in less than 6 months, which for a user base of upwards of 2,000 to 3,000 users, and they range all the way from students just learning to experts in their research domain to people compiling their own software. So very wide base of users. I feel like we had a pretty aggressive timeline in less than 6 months. So what we did was we had an initial testing and software build phase where we had about 2 nodes of each generation minus the Grace hoppers, because those ones we simply installed as Ubuntu because it was the most supported operating system on that newest ARM hardware. And that allowed our research consultants that do a lot of our software builds and our system administrators to actively work on the nodes and get systems running and configured properly to where users could use them. And that took us about a month to a month and a half of work. Then we opened up an early adopter phase where we had 2 to 4 nodes, sometimes a couple of more, configured with Ubuntu. Our scheduling system was set up with a reservation, so you had to opt in to using the newest Ubuntu the newest Ubuntu operating system. And you had to opt in and say, okay, I want to try running my jobs there and see if it works, and try to work through it. We invited some friendly researchers and students. Some of the computer science instructors went, yep, let's get all my students working on it because, hey, they should learn the next thing. And then, as I said, we had a schedule. Our scheduler was set up with that reservation to allow you to select Ubuntu, but by default, you would get the older CentOS operating system. And that was, again, about 3 to 4 weeks on that. We kind of worked out some of the bugs, got the majority of the software that our users might need, and we figured out tool chains that we had to have and which ones were compatible with the newest OS in that phase. Then we rolled into a main phase, and we transitioned about 75% or more of our general use nodes to Ubuntu. We changed it to be jobs got submitted to Ubuntu by default instead of CentOS, and CentOS was a by selection operating system. We do have a concept of buy-ins where a researcher can own their own equipment that we operate, and we left those for the late adopters to give them a chance to continue to do their research on priority access systems without being impacted by the upgrades. We left them for the next phase, which would be the late adopters. So then we moved in another 4 to 6 weeks of that, and we moved into the late adopter phase. We spent 4 weeks in transitioning all the buy-in nodes over to Ubuntu. And we gave them a deadline and said, on this date, we will start transitioning all of the buy-in nodes. If you want to do it sooner, please let us know. And so we had the opportunity to schedule them across that entire 3 to 4 week period. So it wasn't all being done in 2 days. So we had a nice cadence of 30 to 60 nodes a day, with buy-in owners going, hey, do mine now, do them as early as possible. I can't do it until after this date. So we were able to kind of put them into little boxes and put a nice schedule together that allowed us to do those upgrades. As part of that late adopters, we left 4 to 6 nodes of each era. So of each cluster type, which is the years, we left 4 to 6 nodes sitting, running CentOS 7 to allow the late adopters some additional time to kind of continue to run their workflows while they were trying to decide how best to convert their software to the new operating system and Ubuntu. And that gave them time where they could still work on their system, the same workflows that they had used previously. They just had to select that reservation to make sure it got published to a CentOS compute node. And so we gave them 3 to 4 weeks of that, and then we led into the final phase, which is where we're at, where all the compute nodes are transitioned to Ubuntu. So that's the only compute resource operating system we're running. We do have a legacy workload support path using containers that they could run a container under HPC container runtime that would allow them to continue to run their workflows if they absolutely had to. But we will only keep that for some period of time before we completely shut down the software stack that was associated with it. Because of the containers, they're always allowed to do it themselves, but they would have to build any software that they need inside the container, as opposed to using our pre-built software stack of 1,000+ versions, tool chains, and specific software. So that's where we're at now, is in the final phase of we're still supporting legacy workloads with containers and our software stack that we previously provided. Some of the challenges that we found along the way is different distributions of package naming and grouping inconsistencies. So when we needed to install a group of packages, we'd have to figure out the name. Maybe they don't have a comparable grouping, so you'd have to pick out the packages that would make that up. And sometimes you'd miss one and you'd have to go back and add it into the configuration management to get it in there. The Ubuntu released the newest Ubiquity installer, which is their server Ubiquity installer, in about April of 2024. So it was challenging to make sure that XCAT could utilize that installer. It wasn't well supported at the time, and we had to determine where it was reading the partitioning arrangement file so that it would deploy the operating system on the hardware in the hard drives the correct way. So there was some figuring out, debugging that with the XCAT issues with that newest Ubuntu installer system. One of the other areas with Challenger is that local software and module builds. As I said, with 1,000 different software versions and tool chains, it's figuring out, well, what ones do we need? We have to build all that software and get it presented to the user. We evaluated the Easy Stack, that's how they pronounce it, is the Easy Stack, which is a European consortium of high-performance compute centers have kind of deployed a grouping of software for architecture-specific releases, so that if the architecture exists, they've built it and have released it. And it can be used pretty easily to, like, I want to load this compiler and this tool chain, and it's relatively easy to use. However, we identified some issues with the base operating system and the compatibility layer they use, because it is available on any operating system, but once you introduce it, it leaves compatibility failures with the operating system for some system tooling. So it's not ideal in our situation, because we want to present a default software stack to users on login. We don't want them to have to source anything to start using the system. So that really ruled that out, because if you loaded it as default, it would interfere with some system binaries. So we did settle on using locally built software, but we decided to use Easy Stacks, which are used by the Easy system, not to be confused with the wrong spelling. But that is so that we can repeatably build it across multiple architectures so that we can optimize for architectures as they release newer ones, AVX 512 instruction sets, or even the AMD nodes with Grace Hopper, the ARM nodes. We can release optimized for that, and everything in between. We do provide a generic suite of software so that can be used across all of them, because maybe you want to run across every cluster variant and you have to use the generic software for that. It allows us to rebuild it pretty easily and move to the next one. And we have our list of software that's going to get built. It can be incorporated with automated build tooling, such as GitHub Actions or something like that. And then it can be easily rebuilt for different architectures as we decide to release them. We typically use the upstream ones, but we do maintain some locally. We kind of make that decision about effort of maintenance versus how many users are actually using it and how much impact it will have. Does it have a high impact? Well, we'll take on the maintenance burden of maintaining some of that stuff to keep deploying it. We did see some virtual desktop stability in Open On Demand, which is our desktop presentation software. Some of the desktop power management, screensavers, and even Xorg libraries were a challenge for presenting through Open On Demand, which is that desktop presentation suite. It presents a virtual desktop to a user and also allows us to run some other server type software on a per user basis that they get a desktop presentation of. We did manage to work through that. We did have to find an older Xorg library that we can use that's compatible with what we wanted it to do. Excuse me, versus the generic provided Ubuntu libraries. So that was a little bit of work to get through that. The other one we found relates to our job scheduler, which is Slurm. And we realized that the node operating system that you were submitting the job to the scheduler from had to match the requested operating system on the nodes you were going to get. And so we had to do some scheduler logic so that if you submitted from the wrong development node, it would go, nope, you cannot submit to that reservation from this node. Please try again. And we direct them to some documentation that would help them. Oh, okay, I have to go to a different dev node and then do the same workflow from there. And another thing that we found that was a challenge was some of our technical debt in the configuration management code. We had been using CentOS for so long that we didn't really have a lot of support for multiple OS types. So we did a lot of refactoring of that code base to support multiple OS types, and where we could apply them generically across any OS, and then do some notifications to advise of the areas that still had to be worked on instead of just failing and reporting the error. So that allowed us to, okay, we got the stuff that applies generically, that works just fine. And now we can see the list of things that we have to act on before it's ready for general release. So they weren't as many as I expected to see. As I said, we had we have the experience on both CentOS and the Debian derivatives, so it helped us to really do that transition. Some of the successes we had were the easy stacks for easy build, for multi-architecture optimization, and the ability to rebuild that software stack quickly as needed. So we deployed a lot of software and then realized that we had to change routes. And so we had to tear it all down and then rebuild it all again. And using those easy stacks with easy build allowed us to just, okay, rebuild that one, and do it in more of an automated fashion. Our phase migration plan did a good job of getting early on-ramp users and kind of giving us experience with common issues so that we could highlight those issues as people started using them, which leads into our robust documentation. Our research consultants really did a good job of providing some excellent documentation to the users with any known issues that we had experienced, an FAQ section, with resolutions so users could help themselves to resolve issues quickly. And it goes along with our other documentation on the high performance compute, which I've been told from other cluster users across the world that, yeah, they go to our documentation site to figure out how to do things. So, and I think that that was a big success, is having those known issues and FAQs for the users to go in and kind of this is how you can go about transitioning. These are the things you need to do to get your current workflow to work under the new operating system. We had a good team knowledge of configuration management system and deployment tools to kind of identify those issues that we needed to fix and to get those fixes in rapidly. Whenever we identified an issue, we had 3 or 4 people that could kind of put their heads together and come up with a real good solution. And I think the biggest success is that by going through this process and kind of seeing how this works, we're kind of in a better position to migrate to future releases more often. So one of our future plans is to every couple of years look at the next operating system and kind of do that initial testing phase to see, okay, how much effort would it be to transition? How much do we feel that it provides benefit to transition? And it puts us in a position to do that rapid migration to a future release more often if we so desire. So instead of sitting on a stagnant OS for the 10 years of support lifecycle, we could choose to every 2 years move to the next long-term support of Ubuntu, or push it through to the 5 years and jump 2 versions like we did. So I really feel like that's one of those areas that will push us to, okay, let's start evaluating them every time they're released and move towards a more agile response to the operating system deployment. I'll leave you with a few links. There's our site, iser.msu.edu. That's the Institute for Cyber-Enabled Research main landing page. From there, you can find out all about us, some of the research that we're currently doing, and the researchers that have published excellent work using our systems. And there's also a link to our documentation if you're curious how to do things in a high-performance compute center. I provide a link to Easy, the software distribution, because you could use it on any operating system or any Linux operating system to pick up a new software stack that you want to use. There are some caveats to it about how you get it, because it uses an HTTP-based, web-based deployment system. So there's a little bit of file system work you have to do to become a client, but it's easy for anybody, easy and open for anybody to use any of the provided tool chains and software that's available. And they all use all open source software, so none of it is licensed. And then finally, I'll leave you with Easy Build, which is the tooling we use to build all the user-facing software that we use. It's not really interesting to a lot of people, but for those of us that have to build software for users on a regular basis, super helpful to kind of give a description of how the software is built and what options it needs to have that's repeatable and can be done in an ongoing basis. So I'm going to mute myself and bring up my audio back, and I'll open it.
Yep, you muted yourself, all right.
So we'll see how quick I can go back and forth.
Yeah. I've got a couple of questions for you.
All right, go ahead.
I may have missed it, but did you say how many nodes you had?
My apologies. I probably skipped right over that part. It's around 1,100 nodes right now of compute.
Okay.
Pretty sizable cluster. Certainly not the biggest, but one of the bigger research university high performance clusters.
Okay, cool. Can you give us an example of the kinds of things that people are running on this cluster?
We have people running bioinformatics where they're looking at gene sequencing database type thing. We have people doing chemistry analysis to look at compounds and things like that. As I'm not a researcher, so it's hard sometimes for me. We have astrophysicists using it to work on data from the particle accelerator at the FRIB.
Oh, cool.
We have physicists working on research of data that comes out of NASA and the publicly accessible telescope data. We have some
Flow dynamics,
flow dynamics from the engineering labs.
rivers.
And rivers, I believe we've got some forestry people doing research on forest populations and animals type stuff. And then I believe we've got some people in like the humanities department doing some research in linguistics and some stuff like that, some psychology and some. Anything else that anybody can think of that, economics, so that's another big one, is the economics department has a lot of research they're doing.
Machine learning, large language models.
Yes, and some people are actually doing large language model training on the system. We don't run any for anybody, but they're, welcome to train their own models using the available resources for research purposes.
Right.
And if you go to our website, there are links to some current research that people have done publications. We have some really good ones that people. I don't remember them all off the top.
Yeah, yeah. Cool. And then the final question that I have is, did you guys get any help or get any advice from Canonical on moving to Ubuntu?
We talked to, me and another, one of our other sysadmins talked to a Canonical representative. They are early on in their support of the high performance computing environment. So they hadn't really targeted in the past. So they had a really small team of people doing high performance computing and trying to work for that environment. Because we're a very distinctive environment from your enterprise environment.
Sure.
Running servers and web and other tooling like that. So we did get a chance to meet with them and talk with them last year. And then when we've reached out with a question about something, they were happy to answer us, because again, it's a team of 2 or 3 people, one of them a
Sure.
packager, and one of them a developer.
Yeah.
So we did but not as much as I would have thought. We didn't reach out to them as much as I thought we would.
Okay. But you had some guys on staff with Ubuntu experience and so
Debian for decades.
sure, and so you had the in-house knowledge
Yeah.
to do much of it. That's cool. That's it for my questions currently. Anybody else have questions?
I'll just give you my recent experience with Ubuntu, and I was curious if you had a similar experience. I mean, I was writing a web browser automation script to help a realtor out download a bunch of stuff from Dotloop. They had thousands of documents they needed off of there, so I had it, log in, go grab the thing, download it, save it, check the boxes or whatever, and Playwright wasn't working on FreeBSD, so I had to, I just grabbed the latest Ubuntu to put it on, and I found that Playwright was running some weird error. It wasn't working on Ubuntu because the community hadn't quite migrated to the latest version. So I had to find like an old version of Ubuntu that people were still supporting that it worked on, and I feel like that seems to be the scenario. Every time I come back to Ubuntu, I always keep running into that type of situation where there were some heroes a few years ago that got everything working, and then a new version comes out and they're like, I don't want to do all that work again. So they kind of just slow to adopt it.
I haven't seen it for a lot of the stuff we're using, but as I said, we do a lot of the building ourselves. So we're taking source code and building it with the associated libraries. So a lot of that is not, we're not using pre-built packages, so it's okay that they didn't go through the effort of making sure that it worked, because maybe, we've got the expertise to tweak it, to use the right tool chains. And a lot of our stuff is software tooling. So there's very little like user-facing products that we're deploying.
Okay.
We did not go with the the 2404, but it was because it was released too late in our cycle of we've got to be done by June.
Yep.
Yeah, it just came out in April, the end of April, so.
Yeah, it just came out at the end of April, so it was really a little bit leading edge, so we're 2 years behind. And for us, that makes a lot of sense, because it gives us enough lead time to look at the next version. But it also gives us close to the cutting edge of the latest libraries. And is very stable for our users. So I don't know that we've experienced a lot of that. But we also did find that we had to move off a lot of versions of software and not support it anymore because it just requires libraries and tool chains that we didn't feel like it was worth putting in the effort to get working on Ubuntu. So we made a decision about these are the 3-4 tool chains that we support. If it can't be built with one of these 4, then we're not gonna build it because that's old and you'll have to find the new thing and learn how to use it.
Right. That makes sense.
Yeah,
Oh.
I've been using Ubuntu for years, since probably 2005 or 6. But what I keep finding, the latest version, they're not very cutting edge. You know, they're a good solid operating system, but like I've got a couple of servers running 2404, and like I need Node in my as part of my product, and Node.js is up to version 20. Ubuntu is shipping version 12. So that's, they're pretty
They kind
far
of fix
behind.
things a little far back.
Yeah, same thing with Postgres. Postgres is a very, very important part of our software, and I have to build it myself because the version that they're shipping is really out of date.
Yeah, and I found
wish,
that with Debian as well. So when I ran a Debian shop, I tended to, you take base OS and everything else you want. You go get it from source and you get it from the horse's mouth and that's the one you run.
Yeah, and I've been doing this a long time. I'm okay with grabbing the Node.js source and building it, and grabbing the Postgres source, but I just kind of wish I could more easily automate it by just doing an apt-get install Postgres and get what I want.
I agree. That's the one downside I think on Ubuntu is that when they fix something, sometimes it is too far behind for a lot of people's tastes.
Yeah, and these things are changing. I mean, not that rapidly, but there's some features in the newer Node.js system that we want, and there's definitely some features in the newer Postgres.
I think it's a step better than Red Hat's. Where they
Probably. Probably. I haven't used Red Hat in at least 20 years, but Red Hat was pretty far behind too. But anyway, that's my 2 cents. I do like Ubuntu as an OS though.
Anybody else?
Your desktops, were you providing graphical desktops?
So we do provide graphical desktops. The question was, were we providing a graphical virtual desktop? And yes, part of the Open On Demand product, which was written by, is that Ohio State?
Yeah.
Written by Ohio State, available free for use. It's open source software. It provides a virtual Linux desktop. Is the primary use case for us for it, but we also provide some graphical applications, just the application itself without a backing desktop. So a user can go in a lot of our classrooms that are teaching Linux or some development will go and get a virtual Linux desktop. We present users with a Mate desktop of whatever cluster flavor they'd like. They get to select the number of CPUs presented to them, how much RAM they get, and of course, how long they want to have access to it. Some of our older hardware is dedicated to that. So if all you need is a simple desktop, it doesn't have to have the latest features. You just need 32 gigs of RAM and 8 cores. Okay, you'll get it pretty quick because it's all old hardware and the people doing fancy research aren't really using them.
Well,
How are you getting the remote desktops though? The graphical desktops. What are they running on their local machine?
They're getting it in a browser. It's a browser presentation of a remote desktop. Super interesting project and very useful. It works really well.
you know what protocol they're using?
as far as the
Does what?
visual, so they have I think they're using type VNC. And it's encrypted and proxied through the on-demand server, but I wouldn't swear to that.
Okay.
But they're using a VNC type protocol
Yeah, it's no
to
big-
do the
Okay.
graph transmission.
Okay.
But it is reasonably responsive. I mean, you feel like you're sitting at your desktop. Cut and
Really?
paste is a little but
A little wonky. Yeah.
yeah, it has extra steps. You can't just paste anything in there. You have to go through an extra step to allow it access to your clipboard. Which, I mean, that's a browser security. Okay, great. I get it. So that's the answer to that question. I could probably do a little talking on demand one of these years.
Yeah.
I'd like to see that. Is
demo.
there any support for the X Windows system, or is that pretty much
So we
done
are
now?
using X Windows. We don't provide support for native X window connections.
Okay,
You have to either tunnel over SSH and you
Okay.
can,
that's fine.
yeah, so you could tunnel over XSH and pass X Windows information through there.
Okay,
Or
so you can run your X
on-demand, which-
clients and
yeah, you could theoretically run your X clients on the remote side, and tunnel through SSH, with the X Windows protocol. I'm not sure how that will work moving forward with the move away from X11 and over to,
with Wayland and
Wayland. I don't
Yeah.
know. I'm sure that, maybe more users will be, forced into using on-demand, for their GUI workloads because that X11 workflow doesn't work anymore. I don't know what Wayland is using, if Wayland will support passing that over the network.
Well, there's an X server that you can run under Wayland to do that. It's like running X on Mac OS. You can, or even on Windows. You just run an X server on your local machine, and then that can connect to the X clients back on your servers. But it seems
So
like
it'd be
the world is
interesting.
moving away from X.
Yeah, it'd be interesting to see how long that support for X Wayland works and whether it continues to work in a networked environment.
Yeah.
So
Anyone
I
else?
imagine the high performance computing, you got power concerns, and what after the migration, was there a difference in the resource utilization because you were running more later software? Is it more efficient?
We haven't seen big performance degradations or improvements, except where we have done architecture optimized software. So when we optimize for AVX 512 versus the 2014 nodes with like AVX 2, that's where we've seen big increases in performance. When the user is using the native build for that architecture.
That's you're not seeing major difference between RHEL and.
No, we didn't see it.
OS, the OS doesn't seem to be the factor, it's you taking advantage of the architecture.
Yeah, we did not see a major difference between generic OS level running workloads. People have identified, well, we think this is slow, but we don't believe that has been associated with the OS. We had some other improvements going on at the same time that could have affected it. But the big one that come recently is with an architecture optimized software, big improvements. As far as the OS goes, I think the underlying OS didn't change the performance significantly enough to be notable.
And what are you using for your file system layer? Do you have just a bunch of disks?
That depends. File systems in a high performance computing center are always a challenge. Because primarily because we can't tune the workload to suit the file system specifics. So right now we're using a parallel file system. We're using IBM's GPFS, but there are workloads that doesn't work well for. In the way we have it tuned, because we are a general purpose high performance compute center. So we have workloads that have many small files or just a few large files and everything in between. So that is one of the challenges with our environment because it's a general purpose high performance compute. We are moving like home directories were moving off of the parallel file system into a more high performance file system that does a better job with some performance decrease in if you're writing from 100 nodes at a time to the same file system, the same file. Or few files in the same directory. Where that might not work for on a not a parallel file system, it works very well in a parallel file system. You can write from 1,000 nodes all at once to the same file set. That's not a problem. Okay, does caching and late writes and lies to the writing application all the time. So that's a challenge in our environment, and we primarily use a parallel file system, but we're starting to look at changing how we treat home directories to put them on something that works better for individual users. Does that answer the question?
Yeah, and I was just thinking because I love ZFS, and I like how you can set different options on your data sets, and I was curious if that would help. If you knew for sure, like this workload's using big files, you could tweak that record size.
Yeah, and that's one of the problems with using something like ZFS is that you want to tune it to the workload. Well, if you don't know what your workload is going to be any given day, you can't really tune ZFS to your workload. So that kind of keeps ZFS from being a prime contender for our main use cases. We do use some ZFS for various things because they works great for a number of workloads and things that we're doing.
Awesome.
Anyone else?
As a person who has not used an HPC or done anything in there, I'm curious as if I were a user, what things would I have done that would make me care what operating system my programs are going to run in?
I would say that for a majority of users, they don't. As long as it has the software that they need for their workflow, they really don't care what the OS is. They care that it's Linux because a lot of the tooling is written for Linux and a lot of the guides are written for Linux in a lot of the research communities. And you certainly wouldn't want to change to a different underlying OS. There are quirks with operating systems. One thing we saw was that by default, bin sh on most operating systems points to bash, and so everything's fine. But on Ubuntu, it points to dash, which is a slightly different shell than bash. And it doesn't support all the things that you would expect to see in bash. So you can see some oddities there where your users always use bin sh, and well, suddenly it doesn't work on Ubuntu.
Yeah.
So that's one thing we've noticed. In that respect, they would care if they were using some of the underlying operating system tools that might have changed slightly. But
Okay.
I think for the majority, I'd say 80% of our users really don't care what the OS is, as long as the software tooling that they're looking for is available in the versions that they want to use.
And I guess if I were programming and writing my own code, then I would care that the version of Python is available, or Fortran, or what version of the libraries I'm sucking in are available.
Right, and so a lot of our research don't necessarily write their own, what a lot of people would consider code, but they write, let's see, how do I put this? They write they write job steps where things happen and, the pipelines. They write pipelines to kind of use the precompiled software to run some code. And it might have been a researcher or a grad student from 4 years ago that wrote it. And now that we changed operating system and version of the compiler, well, they might have to get another grad student to look into it and rewrite it. Or rewrite it themselves. But we do have users that do care which libraries because they're building their own software from source in a compiled language. But a lot of our users, they're using Python, they're using something based on Python, or a tool that is a similar interpreted language, where they just write the pipelines and the software takes their data and it spits out results, given the parameters that they give it.
Okay.
So
Thank
We
you.
kind of run the gamut between power users and people that know that if I give this software a data blob, I will get an output blob.
So there's lots of users getting command line access. Um, sounds like a lot of them need it, right?
Yes,
Minus-
the vast majority of our users, in, the vast majority of our users interact via the, command. Versus they shell in with, SSH and they get access to a node and then they submit, you can submit an interactive job where you actually get the node. Or the resources you ask for, and then you are actually sitting on that resource, live working, interactive. Or you can just submit a batch job with batch commands, and it goes and does the things that you told it to, and it spits out an output file. So, but the vast majority of our users, excuse me, do interact via SSH and the command line. We do have a large population of users that are using GUI applications, like RStudio, Jupyter Notebooks, and let's see, what's another one? VS Code. Some of them just use VS Code, or code server of some sort. And that's the other one. What's that?
MATLAB.
Oh, MATLAB, and MATLAB's another one that we provide. So some of those GUI applications, that's all they do is they open up a MATLAB session with on demand and then they use MATLAB. So we run the gamut as to what users we're supporting.
Do you have any interesting stories of runaway processes that try to take over too much resources?
I mean, we use C groups, we kill off processes that, you only get the resources you ask for. And I mean, we've had fill up temp, kills jobs, you fill up temp. And we tell them, if they do things that make the system unstable for more than them, we kind of send them a message and go, hey, what you're doing is causing problems. How about you come to us and we'll look through it and we'll help you. That's what our research consultants are for, is to they understand the research that's being done in a lot of fields. But then they also understand the nuances of the high performance compute center. And so they can be that go-between to go, well, this is how your code that you're trying to run to do the research is impacting the other users on the center. So we have had users kill the file system on us because they were doing things that wouldn't help us. Usually it's their problem, they kill their jobs and it doesn't affect the rest of the users. It's a pretty good separation with the scheduler that it doesn't really impact anybody else. But we have had times that they killed the file system because they were doing things that were not happy. The file system was not happy with what they were doing. And that's when we go, oh, okay, hold on, don't you submit any more jobs until we have a conversation and we see what you're doing. Because we gotta figure out a different plan because it's not helping everybody else.
Nice. Right, you're DDoSing our system. They're like, what are you talking about?
That's right. And like I said, we've had them, people do really strange things on the HPC.
That seemed like a good idea at the time to them.
Yeah, to them, it was great. Yeah, perfect idea. It works great. But on the system, that doesn't always apply. So.
But you probably get that on any shared system. You probably, I'm guessing people who deal with mainframes and Kubernetes clusters may have had the same.
Oh, yeah, I'm sure they do. You're running a Kubernetes cluster and you get a developer that launches 10,000